Hello friends, welcome to our YouTube channel. In this video, we are going to learn electricity. Key concepts of electricity like what is electricity or electric current. Then concepts of electric potential, potential difference. Then Ohm's law, factor affecting resistances, resistors in series, resistors in parallel. Okay, then some concepts of electrical power, heating effect of current. So please watch the video till the end, you will understand each and every concepts in detail. Okay, this is Sandeep Sir here from Sandeep Academy Bengaluru. Here admission is open for the academic session 2026-27 for the offline classes as well as online classes. If any one of you are looking for the admissions, struggling in physics, chemistry, maths, so you can join our center. We have 3 centers in Bangalore. One is in Kengeri satellite town, other is in Dubasipalya, third one is in Kumbalgodu. Okay, so let's start. What is electricity? So electricity, it is a source of light and heat energy, yes or no? So what is electricity and how it is produced? Okay, try to understand. We have substances are classified into 2 basically broad groups. One is conductor, other is insulator. So conductors means what? Metals will generally consider as conductor, which will allow the electric current to pass through them, yes or no? So why they will allow the electric current to pass through them? Because they have free electrons, yes or no? They have free electrons. So consider a metal in which free electrons are there. Once you connect this conductor to a cell is a source of energy, right now. So this is positive, this is negative, so this end become positive, this end become negative. What will happen? These electrons will start moving towards the positive charge. Here you know that like charges repel each other. Okay, so here negative, again it will repel in this direction. So all the electrons are moving from B end to A end, yes or no? In this case, so current will be produced in the opposite direction from A to B. So direction of current is always opposite to the flow of charges, negative charges. Okay, fine. So electricity is the practical means of transforming energy to the desired form in which it is needed. And how will you define electricity? Electricity is nothing but a charge flowing per unit time. What is this? Charge upon time. Okay, charge flowing per unit time is called as electricity. Electricity or electric current we can write I, charge as Q. So I is equal to what? Q by T. What is I? Q by T. Am I clear? So charge is generally measured in coulomb, time in second, current in ampere. So if 1 coulomb of charge flows for 1 second, then current is said to be 1 ampere. Current is said to be 1 ampere. Now let's discuss about the electric potential. See the definition: the amount of work done, that is energy spent in moving a unit positive charge from infinity to a given point in an electric field is called as electric potential. Try to understand these concepts. Consider a charge is there, Q charge is there at infinity. I want to move this charge from infinity to point A. So to move this charge from infinity to this point A, okay, we have to do some work right now. So that amount of work done by charge, okay, is called as what? Electric potential. So SI unit of work is what? A joule. SI unit of charge is what? A coulomb. So if suppose 1 joule of work is done to bring 1 coulomb of charge from infinity to a point, then potential is said to be 1 volt. Potential is said to be 1 volt. So SI unit of electric potential is what? A volt. So electric potential is measured in volts. Okay. Okay. Try to understand this. When 1 coulomb electric charge, the value of 1 coulomb is nothing but 6.25 into 10 to the power 18 electrons, is brought from infinity to a given point in an electric field such that work done is 1 joule, then the electric potential at that point is said to be 1 volt. Am I clear? Quantity of electric charge, try to understand. The number of charges, that is electron, which drift from higher to lower potential is called as quantity of charge. So charge SI unit is what? Coulombs. Electric charge is measured in coulombs. C, we are writing capital C. The quantity of electric charge which will deposit 0.00118 gram of silver on cathode when passed through the silver nitrate solution is called as 1 coulomb. This is a definition of 1 coulomb. Okay, it is not there in syllabus, but you should know what is 1 coulomb actually. It is the quantity of electric charge which will deposit 0.00118 gram of silver on the cathode when passed through the silver nitrate solution. This is the definition of 1 coulomb. So, you see electric current, the rate of flow of charge in an electric circuit is called as electric current. So, I is equal to what? Q by T, and unit of electric current SI unit is what? Ampere. We are writing as capital A. Am I clear? Okay. How will you define 1 ampere? You can see, okay, when 1 coulomb of charge flows through an electric circuit in 1 second. Okay, so as you know that I is equal to what? Q by T. So when the charge is 1 coulomb, time is 1 second. So 1 coulomb flows for 1 second, then current is what? 1 ampere. Yes or no? So you can see once again, when 1 coulomb of charge flows through the electric circuit in 1 second, then current flowing through the circuit is said to be 1 ampere. What is the relationship between the current and the number of electrons flowing through an electric circuit? See, actually we have a concept called as quantization of charge. Quantization of charge. According to this, okay, total charge present in a body is always integral multiple of basic charge E. So Q is what? Plus minus Ne. Total charge can be always integral multiple of basic charge. Okay, N is the number of electron which is always a whole number. Okay, it may be 0, okay, 1, 2, 3, it may be negative also. Negative or positive. Okay, now fine. Am I clear? So I is equal to what? Ne by T. So what is the current formula we learnt? I is equal to Q by T. So what Q is what? Plus minus Ne by T. So this is how we can get. The continuous drift of electrons through the body of solid conductor constitute the electric current. As I told you, when you connect a conductor to a cell, suppose this is positive, this is negative. So what will happen? Electrons will move in a one direction, right now, from where to where? B to A in this case. Correct now? So current will be in which direction? A to B. Okay, next we have the concepts of electric potential difference or just potential difference. Try to understand. The amount of work done in moving a unit charge from one point to another point in an electric field is called as potential difference. Okay, suppose there are 2 points A and B, and I want to move this charge Q from A to B. Yes or no? So to move this charge Q from A to B, we have to do some work right now. So that amount of work done to move a charge from one point to other point, okay, now is called as what? Electric potential difference or just potential difference. We are writing this as also V is equal to W by Q. Here in this case, V is what? Potential difference. W is the work done to move a charge from one point to other point. Q is the charge. Potential difference is measured in volt only. Am I clear? So you can see this, when 1 joule of work is done in moving 1 coulomb of charge from one point to another point in an electric field, then the potential difference between these points is said to be 1 volt. Okay, if suppose work done is what? 1 joule and charge is 1 coulomb. So 1 by 1 is what? 1. So 1 volt it is. If 1 joule of work is done to move a unit positive charge, means 1 coulomb of charge from one point to other point, then potential difference is what? 1 volt between the 2 points. Am I clear? Now let's talk about the electric circuit. Okay, electric circuit. So a continuous conducting path between the terminals of a source of electricity such as cell or battery is called as electric circuit. Okay, so we can draw one electric circuit also. You can see this is the lamp we can put, this is the switch, this is a source of current, that is cell actually. Yes or no? If switch is on, what will happen? Current will start flowing through this, the bulb will glow. So this is a continuous path of electric current called as electric circuit, right now. So continuous conducting path between the terminals of a source. Okay, so this is positive terminal, this is a negative terminal. okay, such as cell or battery is called as what? Electric current, electric circuit actually. Okay, open electric circuit and closed electric circuit. An electric circuit in which the flow of current stops because of open switch. If this switch is suppose off, okay, if this switch is off, okay, so if it is open like this, so no current will flow, so you will not get any, bulb will not glow actually. In this case, bulb will not glow. If switch is on or key closed, then only bulb will glow, then it is called as closed circuit. Yes or no? An electric circuit in which an electric current flows continuously because the switch is closed is called as closed electric circuit. That you should understand. See, whenever charges flow through the conductor, there is some opposition offered to the flow of charges, that is called as resistance. Okay, what is resistance? You can see definition: the opposition or the obstruction offered by the conductor to the passage of drifting electron is called as electric resistance, and SI unit is what? Ohm. It is measured in ohm. Is it clear? An electrical conductance is what? Reciprocal of resistance. Conductance is what? Reciprocal of resistance. So conductance we can write as G, resistance as R. Resistance as R. So G is what? 1 by R. Okay, so as the SI unit of resistance is what? Ohm. Ohm we are writing like this. So conductance will be what? 1 by ohm. So we are writing ohm inverse. What we are writing? Ohm inverse. Am I clear? You can see electrical conductance. The reciprocal of electrical resistance is electrical conductance. Conductance is equal to 1 by resistance. SI unit is what? Ohm inverse. Okay, you should also know what are superconductors. Okay, when the resistance of the conductor becomes 0, then it behaves as what? A superconductor. Try to understand the particular temperature at which the resistance of the conductor becomes 0, that is, it does not offer any resistance to the passage of electric current, is called as critical temperature.